All right. So we're going to continue talking about fossil fuels today. Okay. We'll start by kind of defining what is energy. Okay. So if I came to you and said, "Man, you have a lot of energy today," what would I mean by that? Want to give me a definition of energy, Sandy? Okay, very good. You're very ready to go. You can move. You can do stuff. Landon, what else? Maybe adrenaline in your body. Okay. Hannah? You're what? You're fueled up and ready to go. Good. Okay, what if I said, the power is out and I have no energy for my room? How would we define energy then? Ethan?
You have no, but you can't turn on. You can't, like, so if I wanted to turn on the light, I had no power, then no energy would be sent to the light.
Okay, very good. Nicholas, one more. We're going to get that in just a little bit, actually. Bella, one more.
There's no electricity.
There's no electricity. Good. Okay. So movement is an example of energy. Power or electricity is an example of energy. So in general, we're going to define energy as the ability to do work. Okay, that's the first part of your note. Energy is the ability to do work. Whether that work is turning on the light, whether that work is powering something, whether that work is moving your legs, moving your arms, all of that is the ability to do work. Every action is caused by energy. Energy makes things warm, makes them move, and makes sounds and light. Okay? So energy comes in tons of different forms. We have mechanical energy, the energy of motion, as in moving your body. We have electrical energy, we have sound energy, we have thermal energy, lots of different kinds. Okay? But we are going to focus today mostly on electrical energy. Okay? In our daily toil, that means in our daily job, our daily life, we use a ton of electrical energy. Okay, this should be in your notes. In our daily toil, we use a ton of electrical energy. Okay? The computer is being powered by electricity. The projector, powered by electricity. The air conditioning in this room, powered by electricity. The light, powered by electricity. Okay? My pointer here, my clicker, powered by electricity. Now, batteries, but still electricity. Okay? Now, the question is, where does this electrical energy come from? If I want to power my computer and I plug it into the wall, okay, how does the wall give my computer energy? What do we think? Is the wall magical? Does it create energy? Reagan?
Basically the whole screw or the wall has electrical energy flowing through it, but through the outlet.
Okay, so this wall has electricity flowing through it, and then into the outlet. Okay. Through the wires. Okay, good. So he's right. If I were to make this wall clear for a second, you would see lots of wires coming to and from this outlet down here. Okay? Now, where do the wires get the energy from? Landon?
So the wires get the electricity because the electricity inside the wire. And they're getting it from different energy sources.
Okay. Okay.
And that's the output of this is something that is experienced energy when it's done with the
Okay.
but sometimes if you plug an outlet in the ground road, you see a little light and
Uh-huh.
shop.
Uh-huh.
And then you put it in the
Mm-hmm. Correct. Okay. All right. So we've gotten to there's wires in this wall. The wires get the energy from some other power source. Where does it come from? Davin?
The power plant?
The power plant. Okay? So the wires in this wall go all the way to the power plant.
I mean, it goes through a generator, which is hooked up to power lines, which is hooked up to the house.
Very good. Okay? So, much of the electricity that we use is generated at a city power plant, far from where the energy is needed. Okay? We don't have a power plant out back that creates the energy for our school building. Okay? There is a Louisville power plant that creates power for all of the Louisville buildings. Okay? So Davin's right. We have wires in this wall here that connect to the building generator, which connects to the power lines outside. You know, when you drive down the street and you see those power poles with the wires that go like this? Yeah. Okay? Those power lines are connecting our building generator to the power plant. Okay? Generally, the power plant will look something like this. Wires conduct the electricity from the wall all the way back to the power plant and then connected to the devices that we use. All right? Now, this is what your typical power plant will look like. I had an older brother. I have an older brother, Alec. He lives in Orlando. He used to work at a coal power plant. It's called OUC. And they provided power for pretty much the entire city of Orlando. Okay? By burning coal, like big chunks of black coal, literally. Okay? And it looks something like this. Okay? There's a lot of steam, a lot of smoke, a lot of pollution coming out of the power plant. But the thing is, if the power plant shuts down, or if it gets broken, or there's some problem with the power plant, if it's not producing power, the whole city shuts down. The whole city, all the power supply shuts off. Okay? Now, if our building generator shut off, all the power in our building would go out. Okay? But the middle or the upper school building might still be okay because it has a different generator. Okay? If the power pole, which all of our buildings connect to, if that blows, then our whole campus runs out of power. You see what I'm saying? Okay. It kind of depends on which part we're talking about here. Okay? But these power plants, okay? The power plants are creating energy by burning what we call fossil fuels. Okay? This is in your notes. One type of energy is fossil fuel. Now, this is the most common type of energy. But there are a lot of downsides to using that as well. First, let's talk about what fossil fuels are. One type of energy is fossil fuels. Okay? Fossil fuels are energy resources that are derived or gotten from the preserved remains of organisms that lived, some scientists believe, millions of years ago. What we just learned on Friday, what do we call the preserved remains of organisms? The preserved remains of once living things. Bella?
Fossils.
Fossils. Good. The fossil is the imprint of that organism into the rock. Yes? Okay. If I have a fossil of a fish, I can see the imprint of that fish's body in the rock. Yes? Okay. Now, I'm going to go back to the other side for a minute. Here we go. This is the same kind of diagram we drew to show how fossils are made, correct? Okay, so these little black chunks in the sediment layers, okay, this is where the fossil would be formed, right? Okay, so this, let's say this is Fishy down here, okay? Fishy died, he was covered up by rock sediment. Now, what has to happen in order, okay, well, hold on. If Fishy dies and gets covered up by sediment, before his body decomposes, that will form the rock, correct? Okay, well, what you have to know is that all living things, fish, animals, plants, bacteria, anything that is living contains carbon in its body, okay? Carbon is an atom. It's number 6 on the table back there. It's got the big black C on it towards the top of the chart, okay? That atom is what is inside bodies or living things that have energy in them, okay? When something dies, there is still energy stored in that body. Okay? You can't just use up all the energy. Now, what happens to that energy once it's covered up by all kinds of rocks and sediment? Okay? It doesn't just disappear and it doesn't decompose. It's still there. Okay? Now, if that remaining carbon from the living thing, okay, gets covered up by enough sediment, okay, the more sediments that pile up on top, the more pressure is increased on the fossils down here, correct? Okay? So all this carbon down here is being stored up. There's tons of pressure being put on top, and there's tons of heat being added from the center of the earth. Okay? If those conditions are just right, that fossilized carbon, that remaining carbon, can be turned into a fossil fuel. Okay? It will form one of three things: coal, oil, or natural gas. Okay? If we then dig a hole down into the earth and pull up this coal, oil, or natural gas, we can then burn that to create energy. You see what I mean? Okay. So, the three examples of fossil fuels: coal, oil, and natural gas. Oil is, you can see these kinds of structures out in West or even South Texas. These are oil rigs or oil derricks. Okay? These machines, when they're going up and down like this, okay, they're drilling into the earth looking for oil. Okay? Natural gas. If you have a gas stove or even a gas fireplace, that's what you're using. Coal literally looks like big chunks of rock, of black rock. Okay? My brother that I mentioned, he worked at a coal power plant. They burned this stuff to create energy. One year when he was working there for Christmas, he gave everyone like a joke gift, and he gave us all literal big chunks of coal. Kind of funny. Okay?
Were you rude to him?
No, he was just being funny. Were you rude to him? He gave us an actual present too, but as a joke, he had us all open these gifts with like big rocks. Connor?
Speaking of fossils, so me and Nick were riding our scooters yesterday, and he found this. I think he found a shell under a rock. So fossil.
Cool.
So it also apparently like the area like there was actually one to see, and I found one of the fossils.
Or maybe even like a river or a stream or something.
Yeah.
Cool.
And can I bring it tomorrow or?
Yeah. All right, Landon and Hannah, then we have to move on.
I remember we and Emily I remember we were in kindergarten in the same class. I remember the first one of these two, we had these children. And every day we would always put them in the whole week and take them up with them so we would have
Oh, yeah.
Yeah. And they're like, once we got like, once we were like, so we had days that and then we got it's probably next to the.
Maybe not gonna find that.
It's probably not gonna be different fossil too.
Mm-hmm.
Probably not gonna be in the real good, so it could be a little bit.
Sure. All right, Hannah. This one? Okay, so fossil fuels. 3 types: coal, oil, and natural gas. Okay? Any of those 3 can be burned to create energy. Now, when they're burned, that releases a lot of pollution into the air. Okay? So scientists begin to think, okay, that's not so great either. The other problem is fossil fuels are what we call non-renewable. Are you good? Good? Okay. Fossil fuels contain stored energy from the organisms that died and decomposed. Okay, like I said, the energy in the organism cannot just disappear. It has to go somewhere. So when we burn those fossil fuels, we release that stored energy and we use it in a different form. Most of the time, we use it in the form of electricity. Parker?
Why would it be a non-renewable resource? Because animals can keep living
Good question. I'm going to get that in just a minute. Landon, make it fast.
Also, a lot of people know this, but not a lot of people know this. You actually do
You actually what?
burn calories.
Yes. As long as your body is alive, you are burning calories. Okay. So, it's a little bit easier to understand talking about stored energy when talking about animals or living creatures. But it's also true that plants have stored energy. Okay? In plants, the stored energy originated or started as sunlight that was captured by plants when they produced organic matter as a result of photosynthesis. So, the sun is the only object that can create its own energy. The sun itself is a huge ball of burning gas. Okay? When that gas burns, it releases light, which is a form of energy. Okay? And plants are kind of cool. Plants are the only thing that can take sunlight and convert it directly into food. Okay? Which the plant then uses the food to create energy, just like your body uses food to create energy as well. Okay? So this quote-unquote fossilized sunlight or trapped sunlight inside of the plant is stored in the form of carbon, the same way it would be in a living thing's body. Okay? And is released through heat when it is burned to generate electricity. Okay? So if a plant gets caught up in layers of sediment and enough heat and pressure is added, that stored or fossilized sunlight or carbon, okay, can also turn into coal, oil, or natural gas. All right? Think about it. If you eat an apple, right? The apple came from the plant. The plant got the energy to grow that apple from the sun, right? When you eat the apple, the carbon in the apple goes into your body, which your body then uses for energy. Okay? So in a way, after going through lots of steps, you are processing energy that started from the sun. Okay? Energy is never created nor destroyed. It just changes form all the time. Okay? So now your body has the energy right from the apple. So let's say you go on a mile run. Well, when you're running, your interaction with the air molecules creates friction. Okay? It's a different form of energy. So it's constantly just being transferred from one thing to the next. Okay? Quickly. So, here's the thing. If we have fossil fuels, and fossil fuels work great, why do we need green energy? Now, green energy is when we use other things besides fossil fuels to create energy for the earth, but we call it green because it's better for the planet. Okay? It doesn't produce as much pollution, it's easier for living things, etc. Okay? So, how do they compare? It seems like this would be a better option, right? Less pollution, we can find it more easily, we're not burning fossil fuels, it doesn't take as long to create, etc. But there are some downsides. Okay? So, 97% of the fuels that we burn, Connor, are some type of fossil fuels. Okay? Generally, when we have a power plant or some kind of structure that's creating power for a building, Nicholas, you should be writing, 97% of the time is going to be some type of fossil fuel being burned. Okay? Now, here's the problem. Fossil fuels are a non-renewable form of energy. Let's talk about that word renew. How would you define the word renew? What does that mean? Trinity? To make or create again. Good. How about when you have when you rent a book at the library and you want to renew that rental? Hannah? You're going to just do it over again, right? Do that rental over again. So, if something is non-renewable, what does that mean? Reagan?
It means that it cannot be done again.
Very good. Cannot be done again. Fossil fuels are non-renewable. Okay? This means that once they are used, they're gone. They cannot be used again. This is kind of how we feel. Okay? Eventually, if we use up all of the fossil fuels, we're going to have a big problem. Okay? Let's take wood, for example. If I burn a log of wood for a fire, okay, once I burn it down to ashes and embers, what else can I do? Nothing. It's gone, right? I can't use that wood again for anything else. It's gone. Same thing with fossil fuels. Now, it's kind of hard to find fossil fuels, okay? Oil, coal, natural gas takes a long time to form, first of all, right? Fossils we just learned take hundreds and hundreds of years to form, correct? Okay? So, forming them takes a long time, but we burn them up like this. I mean, we just talked about we're using fossil fuels all the time, right? So if we run out of fossil fuels, what's going to happen? Big problem, right? We're going to run out of energy. We're not going to be able to power our buildings. Okay? You can't even, someone said in the last class, oh, but what about Teslas? They could still run. Well, actually, no. If the power plant can't create the energy, the electricity, to charge your Tesla, you still can't drive. You see the problem here?
Yep.
You got a big problem. So, scientists begin kind of thinking, hey, what can we do? What are other ways we can get energy that do not involve burning these precious fossil fuels? Okay? A word we're going to talk about is sustainability. What does the word sustain mean? Let me give you an example. If you eat a lollipop for breakfast, that is probably not going to sustain you all the way until lunch. But if you eat a waffle and eggs for breakfast, that's probably going to sustain you all the way to lunch. So what does that word mean? How could we define sustain? Ethan?
Like, hold off.
To hold off, okay. Hold off what? Let's go back to my example. The lollipop will hold off until lunch. What is it holding off? Or it will not hold off until lunch.
So when you move to the power plant, it will not hold your hunger off.
There we go. It will not hold off your hunger. Okay? How else we define sustain? Is this energy going to sustain you all the way until lunch? Landon, sorry. She's in the last class, so sorry. Go ahead. Davin, face this way, please. Yeah? Okay, so what does sustain mean?
Sustain for kind of like what it says, like the sustainability refers to the ability to prevent the energy needs of the farming, so it's kind of like it's really like holding off until like you're ready to do something.
Okay, so it's giving you enough for the time, right? Okay.
And also green energy is better and better because the sun is really actually pollution.
That's debatable, but it is a concern, yes. Okay, sustainability, okay? In terms of green energy, sustainability is the ability to provide for the energy needs of the current world's population without harming the environment for future populations, okay? So, is the way we're getting energy right now, is that sustainable for a long time? Is it going to hold off problems? Okay? Is it going to give us enough? All right? That's the question. Green energy, okay, which this just means energy, ways of getting energy that does not involve fossil fuels, okay? That's better for the earth, which is why we call it green, okay? Is more sustainable than fossil fuels. Green energy has a lot of benefits, okay? It does not create the pollution that fossil fuels do. But here's the problem. Green energy takes a lot more of it to give you the same amount of energy as this much fossil fuels. Okay? So let me give you this example. For example, solar panels. Okay? That's a big form of green energy. It's becoming more and more common nowadays. It takes this much solar energy to give you the same amount of power as this much fossil fuels. Okay? Fossil fuels are much more efficient. It takes a lot less of them, but you do have the downside in that they are non-renewable, in that they create pollution, They kind of cause problems within the environment, etc. Okay? So, what are some examples of green energy sources? Okay. Green energy refers to alternative sources. This means different. Alternative sources of energy that are more safe for the environment. These resources are cleaner for the air and renewable. Okay? These are renewable. Once you use them up, you can use them again. What I mean by that is this. You can replace it a lot more easily. So this is getting back to your question. Fossil fuels are non-renewable because they take so long to replace. You can't just create fossil fuels overnight, right? They take many years to create. Green energy, though, let's take solar panels, for example. Sun comes up every single day, right? Some days more than others. But every single day we could charge back up, so to speak, using solar energy. So we get it every single day. Does that make sense? Ethan?
So it's not the solar panels that are renewable. It's the sun.
Correct. The source that you're getting the energy from. Alright, so let's go to some examples. Examples of green energy. First one is the one I've been talking about. Solar energy. Number one, solar energy. First example. In solar energy, this type of green energy uses solar cells to generate electricity using light from the sun. Okay, I'm going to go back to this. Look up here real quick. It looks like this. Okay? If you've ever seen these big black panels, sometimes they're on roofs of houses. A lot of times they're positioned out in fields like this. Okay? Even sometimes above tiny little electric devices, kind of like this. Okay? These are all solar panels. Each of these little squares is some combination of solar cells. Okay? These little these little devices, they absorb the energy in the form of sunlight, right? If you ever put something outside in the sun and it gets really, really hot, okay, that's absorbing energy from the sun. But these solar panels can actually convert that heat and light energy into electricity. Okay? So, with this speed limit example, okay, and go back to this so you can write. With the speed limit sign, that sign, the solar panel for the sign, is absorbing the sunlight all day long, okay, and converting that into electricity to power the sign. Okay? All right, so the question then becomes, Ms. Horseling, will that actually work at nighttime? Yes, it will. Not because it's absorbing sunlight at nighttime, but because during the day it has absorbed enough and stored some up for later. Okay? Now, if nighttime were too long and it ran out of power, it might shut off before the morning. Okay? But those solar panels can take in energy as well as absorb it and store it for later. Okay? The last picture I had in the bottom there was of a car with solar panels on top. Okay? That was an experimental design. The car actually did function, but it only went, I think, a max of like 40 miles per hour or something, which isn't even fast enough to go on a highway. And I don't think it would run for very long, was the problem. Okay? So, often panels of many solar cells are wired in a circuit and connected to other components to produce an electrical current. Now, this seems like a great solution, and it is. Solar panel cells work great, especially in areas like Texas where we have lots of sunlight. Okay, Alaska, maybe not so much. They don't get a whole lot of sunlight there. Okay? Not as much as we do, at least. But the problem is solar panels are expensive to install. Okay? And it takes a lot of solar power to get the amount of energy we need for our environment. Okay? So a lot of environmentalists will say, well, why don't we just switch the whole world over to solar panel and stop burning fossil fuels? Okay, well, that would take a lot of money that we don't have, letter A. Okay? Letter B, solar panels will not work in all places. We just talked about how Alaska, right? Because of where Alaska is positioned, they get multiple months of just pure darkness. Okay? So they're not going to be able to get energy there at that time. You see what I'm saying? Mm-hmm. Okay? So there are positives and there are negatives as well. No, hold on. I gotta keep going. We're gonna run out of time. Next example, wind energy. Wind energy. This is the form of green energy that is kind of gotten from the wind moving objects. Okay? So this is what Ethan said, well, what about a hand crank? Okay? When I was in college, my mom got me, or Nicholas, I'm so sorry, thank you. When I was in college, my mom got me a flashlight in case we had like a power outage or whatever in our dorm that was powered by a hand crank. Okay? So I could turn the flashlight on, and then I would kind of like pop out the little crank thing, and the more I cranked it like this, the brighter it got. Okay? Now, then the slower I cranked it, the dimmer it got. All right? But that was a tool that was powered not by, I think it had backup batteries, but it was powered not by electricity, but by motion. Okay? Have you ever seen those machines, or like seen a commercial maybe of someone who's biking, right? And the bike is what powers the machine. If they stop biking, the machine shuts off.
Yeah.
Okay? Same kind of idea. But in this example, the movement is not caused by a hand crank or a bike or anything. The movement is the wind blowing what's called a wind turbine. Okay? It looks like this. Have you ever seen these? Okay? The wind moving these propellers, okay? The propeller, the machine in this actual pole, harnesses that motion and converts it into electricity. Okay? Again, really great for windy areas out in West Texas, Wyoming, the Great Plains states. Maybe not so great for New York City. Why? Because they don't have a lot of wind there. Second of all, they don't have space for this. New York City is jam-packed already. They ain't going to build any of these in there. Okay? All right, so for your notes, wind energy can be transferred into electrical current using the motion of the wind. Long blades on the wind turbine turn in the wind and are connected to a generator that produces electricity. Okay, so the wind moving those propellers, causing or creating motion, which is then transferred into energy. Okay, I'll do Davin and then Bella, and we gotta move on to make it fast. Davin?
In summertime, in Alaska,
Mhm.
days can be up to 80 hours.
AD?
80.
But a day is,
Zero.
I think you mean 18. Now they may have 80 hours straight of pure sunlight,
Yeah.
but it would be more than one day. But yeah. But yeah, because of where Alaska is positioned on the globe and its tilt and stuff, or the axis tilt, it has some wacky weather.
Yeah.
And Bella.
I think this was 2 years ago, but my family went to Mexico and we saw like a field and it had a bunch of those.
Mm-hmm. Yep. They are common in more flat, windy areas. They can be a great source, but again, it takes a lot of it to get the energy we need, and it has to be in the right kind of area for it to work. All right, next example, geothermal energy. Now, someone raise your hand and tell me, what does the root geo mean? Reagan?
Earth.
Thank you, Earth. What does the root therm mean? Parker? Temperature or heat. Okay? So geothermal energy is based off of heat from the Earth. Have a bigger head up. All right. So this comes from steam that is produced by hot water underground. Okay, so finding a warm pocket of air deep in the Earth's surface. When you drill down and release that steam, the steam then turns a generator, which produces electricity. This is not necessarily as common. I think it's a little bit harder to find these pockets of air in the Earth. But the geothermal plant would look something like this. I'll go back in a minute, but it would look kind of like this. Okay? So this machinery is drilling into the ground, looking for these warm pockets of air that the steam looks like it's coming up. I don't know if it's coming out here or here or here or whatever. But either way, the steam is what's powering this plant, and they're converting that into electricity. Okay? Trinity.
That happens if they start to do that in the area that's been raining on. It's been raining more.
Oh, good question, because they're releasing more evaporation into the air. I don't know, actually. I would think if there was enough of it over a long period of time, I would think it would change it a little bit, yeah. But I don't know that it would change the entire climate necessarily. That's a great question. All right, next example. Hydroelectric. What is hydro? What does the root hydro mean? Landon? Water. Very good. Now, your first thought should be, wait, Ms. Rosling, this doesn't work. Water and electricity do not go together.
Mm-hmm.
And you're correct. They don't. Okay? Hydroelectric plant, though, this is using the movement of water to create energy. Okay? So, uses moving or falling water to spin turbines that generate electricity. Okay? Now, based on that description, would it be a great idea for us to have a hydroelectric plant on Lake Lewisville?
No.
You say no. You're correct, but why? Connor?
It's not that much moving water.
Very good. The water is not necessarily moving very fast. The faster the water moves, the more motion is created and more energy is created. Where would be a good place to have a hydroelectric plant? Nicholas? Niagara Falls. Excellent. Any other place? Hannah? A really fast river. Rapid. Ethan? The Arkansas River. Okay. Never been there, but probably. And not Davin.
What about the Brazos River?
The Brazos River? Potentially, in more fast-moving parts, maybe. Okay. Now, the other thing they do is they build dams. Okay. So, for example, the Hoover Dam. I think this is actually the Hoover Dam. Either way, the idea is they build this gigantic dam blocking all of that water from moving. Then they open one little tiny slot and funnel all of the water into that one spot, which creates a huge rush of water in that one area. Okay? They then use that to create motion and harness it into energy. Pretty smart. Okay? The way it works is like this. If this is the dam up here, okay, down here maybe is where they let the water come in and flow. Okay, very skinny, so it's flowing very fast. The moving water spins this propeller kind of turbine thing like this. Okay, and that turbine is connected to the generator, which takes the motion of the spinning turbine and converts it into electricity. Okay, Ethan.
Going back to the solar panels. Since the moon reflects from the sun with light, so why wouldn't solar panels charge at night?
They may charge a little bit, but it's still going to be much less. Probably not enough to power the object, is my assumption. Okay. All right, last example, and then we'll get to some. I'll show you. I have a video to show you, and then if we have time, we'll do questions. The last one is biofuels. Last example for us. What does the root bio mean? Nicholas?
I mean, life.
Life.
So, I think about the business minute. I don't remember they have a talk to triangle.
Oh, cool. I don't know. I've never been.
I might have not been. I have not actually been, but that's what I remember. But it has been here, and I remember going on that big person.
Like the bridge? Yeah, I bet. That's awesome. All right, biofuel. So this is fuel that comes from a living thing. So it comes from biomass or plant or animal materials that are burned for fuel. For example, wood. That would be a biofuel. Now, biofuel typically produces a very small amount of energy, but it can be done. Okay? Couple examples. Ethanol. The next time you go to the gas station with someone who's filling up their car, look at the gas pump and see if there is a percentage of ethanol. Okay? The last couple of years, ethanol has become much more popular. But ethanol is a type of oil produced from fermented crops like sugarcane, corn, and sorghum. Corn is a big one. Okay? It's a fermented crop that when you burn it, it releases the energy stored in that plant. Okay? And then the last example is biodiesel. This is vegetable and animal oils or fats that are burned as fuel in diesel engines. Okay? There are actual farms that they grow crops specifically for biofuels. Okay? Like in this picture here. Okay, here we have a kind of a corn crop farmland here, okay, that is being grown, oh, it looks like corn at least, is being grown specifically to be used for biofuel. Okay, I want to say, I believe I read this somewhere, that you can even use plant or animal waste, like dung and poop. Okay, kind of gross, but you can because it still has carbon in it. Okay, and then just a little like clip art of just showing that you can get gas and things from plants. Okay, all right, let me show you this video, and then we'll get into